In yesterday's class, we were trying to understand permissions. Okay, file and directory permissions, user groups, others we have discussed, and also how you can log into your instance as a normal user, how root user controls the permissions of other users that we have seen in our yesterday's class. I told you right earlier, initially we'll cover a little bit of AWS and a little bit of Linux so that we can start DevOps. So we have covered initially basics of AWS, now basics of Linux. Now we are good to start with DevOps. Again, I'm saying AWS is not over it, Linux also not over it. We have covered enough to start DevOps. That means if I start DevOps, you will understand DevOps. Okay, so that's what. Don't think that we are done with AWS and Linux. No. Many topics are there. Going forward, we will discuss. Got it? Fine. So whatever commands that we have discussed so far, those we are going to use extensively in DevOps now onwards. Got it? So I'm assuming that you are good at Linux. And yeah, let's get started with the DevOps today onwards. The first DevOps tool that we are going to start with, that is Git. Okay, we are going to start with Git. This is one of the DevOps tools. I have a document, guys. Let me just open the document. Stay on the line. Let me open the document. Stay on the line just for 1 minute. Yeah. I hope you can see my screen, right? Every one of you, please confirm. Can you able to see my screen? Just type yes or no. Fine. Yeah. Let's get started. Before you understand Git, you must understand one important word, that is source code management. Can I use blue color? Right. Before you understand Git, you must understand one important word, that is source code management. SCM we call source code management. What is source code management? Source code means what? Whoever writes a code. Whoever writes code, that is what we call source code. If you write any code, that is what we call your source code. If I write any code, that is my source code. Right? Whoever writes code, any code, that is what we call source code. Management means what? Adding, editing, deleting. Correct? That is what we call management activities. That means here, source code management is a storage. It's just a storage where we store the code. That's it, nothing more than that. Where we store the code. Apart from storing the code, we can edit the code, we can delete, we can modify, you can append, all you can do edit operations. Got it? Source code management is a storage where we store the code. Apart from storing the code, we can do all management operations. We can edit, we can delete, we can modify, all that stuff. That is what we call source code management. Then who all need this one? Whoever writes a code. Correct or not? So if I write any code, I need some place to store it. Right? That means I want this one. If you are writing any code, you also need some place to store it. You also need this one. So in companies, who all need the source code management? Developers, because they write a lot of code to design an application. Testers also, because they write many test cases. Test cases we call. Okay, test cases means by using those test cases, they will test. I'll tell you, going forward, you'll understand that one clearly. Those test cases also kind of code only, in the form of code. So they also need source code management. And DevOps needs, we are going to write many scripts. Those also you'll understand going forward. We need many scripts because we are going to automate many things. Those scripts we are going to learn in Ansible, Kubernetes, Terraform. We are going to learn. That script also kind of code only. Right? That means we all need a place where we store our code. That's why we all use the source code management. Understood? Remember that. Developers, tester, DevOps needs, and also whoever is dealing with the code, any type of code, they also need this one. Understood? Mainly for us to store the scripts. Apart from storing these scripts, we can edit, we can delete, we can modify, all that stuff we can do. That's why we need the source code management. Understood? Right. Different people from different teams can store code simultaneously at a time. Different people from different teams can store code simultaneously at a time. Everyone's code will be stored separately. Okay, no confusion, no overlap, no conflict, nothing. Assume that it is a bank. Any number of people from any places, any country, any state, they can save their money. They can create their account, they can save their money. No conflict, no confusion, no overlap, nothing. Correct or not? Apart from saving money, you can withdraw money, you can apply some loans and all, right? You can do many things, correct? Here also same thing. So different people from different teams can store code simultaneously. Everyone's code will be saved separately. Everyone's code. Clear? Yes. helps in achieving teamwork and acts like a pipeline between offshore and onshore teams. For example, this is my source code management. We have two teams are there. One team is in India. One team is in UK. Okay, India and UK. Now, assume that these two teams are working in one project. Assume that IRCTC, they're working together in one project. Now, what actually happens? Let's say we are working together in one project to create this IRCTC application. Today, we have written 10% of code, 10% of code, just assume. Once we finish writing code, then at the end of the day, before we leave, then what we do, we store that code here. We push that code to source code management. We finish our work. Now for UK team, for them it's morning, for us it is night, means for them it is morning. So what they do before they start their work, they pull existing code and they add 10 more percent. That became total 20. Once I finish their work, they push back. Now it became total 20. Correct? They leave their office. For us, again, we need to start. Before we start our work, we pull existing code. Then on top of that, we'll add some extra code, 10%. Then again, we push. Like that. That means even though our geographical locations are different, we are working as a team. Correct or not? Right? That's what it helps in achieving teamwork. Because of this, we are working as a team. Correct or not? Right. That's why it helps in achieving teamwork. It acts like a pipeline between offshore and on-site teams. Offshore and onshore. This is offshore team. On-site means what? On-site or onshore, where my client is sitting. So it's a kind of pipeline. Correct? So we are sending, they are pulling, they are pushing again, we are pulling. It's a kind of pipeline. Correct? Pipeline. We are connecting this one, something with a clamp. It is a kind of clamp connecting two pipes. So it is act like a pipeline between offshore and on-site teams. So that we can communicate with each other seamlessly, and we can share the code. Right? Then tracks changes at minute level. Assume that you have stored 1 lakh lines of code, 1 lakh lines of code here. And tomorrow someone deleted one small dot from 1 lakh lines of code. Still that will be tracked. Everyone will understand who deleted that dot. Say at minute level, we can verify who did what, at what time, why he did everything. So it is very secure. Means if your intention is to manipulate the code, you cannot do it. Everyone will come to know. Understanding, right? You add one small dot, you delete small dot, everyone will come to know. So that level of security is it tracks changes at minute level. It is pretty secure. Got it? Right. See, you have a bank, suddenly 1 rupee got deducted from your bank, 1 rupee from your account. Right? You will come to know, right? Immediately. Correct? You can go to bank, you can ask them, hey, why 1 rupee got deducted? Even though it's a small money, still you can track, you will understand why money got deducted, you can raise a complaint, right? Correct or not? Same here also. That is what source code management. See guys, bike is a concept. We have different bikes are there, like we have Bajaj, we have Yamaha, Royal Enfield. Correct or not? Different companies are providing bikes. Right? Clouds are there. We have cloud providers are there. I mean, cloud is a concept. Different cloud providers are there. AWS is one cloud provider. Azure is one more cloud provider. GCP is one more cloud provider. Correct? Right? Here also, source code management is a concept. Different companies are providing these source code management tools. Okay? Those are Git, SVN, Perforce, and ClearCase. Git, SVN, Perforce, ClearCase. Different companies are providing their tools. Those are Git, SVN, Perforce, ClearCase. SVN means subversion. Out of these bikes, which bike that you purchase? The one that you like. The one you find more advantages. Correct? In the same way, which tool that we are going to use? Git. Why? Because it's the most advanced tool. We are getting many advantages. That means here you take any tool. All these tools are source code management tools only. That means you take any tool in which you can able to store the code. You can do all management activity. You will get all advantages. You take any tool. But you need to pick the one which has more advantage compared to others. That's why we are picking Git, because it's the most advanced tool. We are getting so many advantages. Got it? Source code management is a concept. Different companies are providing their respective tools. Those are called source code management tools. Understood? So Git is one of the source code management tools. Source code management is a concept. Okay, Git is a tool by using which in which we are getting all the source code management advantages. Till here, understood or not? Yes or no? Everyone, please confirm. Till now, whatever we have discussed. Type yes or no. Right. Fine. Yeah. Now we need to understand important terminology. You should understand a few things. Oh, no, it is clear. You can see my screen, right? Every one of you. Fine. Let's take an example of two persons, two people. One is Mr. Sai and the other is Mr. Hari. Okay? Take an example of two persons. One name Mr. Sai, other name Mr. Hari. Sai is sitting in Mumbai, Hari is sitting in London. Just assume, okay? These two guys are working in one project, that is IRCTC. These two guys are working on one project, that is IRCTC. But their geographical locations are different. Sai is in Mumbai, Hari is in London, right? So what they are going to do? First, Sai, guys, focus on only where I'm focusing, where I'm pointing, where I'm writing something. Don't worry about other stuff. Got it? Yeah. So what Sai is going to do? Sai is going to launch one EC2 instance. Sai is going to launch one EC2 instance. You know how to launch EC2 instance, right? Okay, he's going to launch one EC2 instance. Could be Windows or Linux. Let's assume it is Linux. After launching instance, he will go inside the instance and he will install Git. He will install. Already you know how to install yum install git -y. Already we have installed that in package commands we have seen. Right? Sai has installed one package called Git. Then what Sai is going to do? Sai is going to create one folder directly. mkdir Mumbai Git. mkdir Mumbai Git. After creating directory, he will go inside the directory, he will go inside. Then he will run one command called git init. Git init. Git init means what? Initializing Git. Initializing Git. I'm repeating. Sai is going to launch one EC2 instance. Then he will install Git. Then he will create one directory. He will go inside directory, he will run one command called git init. The moment he runs that command, immediately that directory will be divided into three stages, automatically, three stages. First one, second one, third one. You can see. First stage, second stage, third stage. 1, 2, 3. Automatically, that will be divided into three stages. Three stages. Clear? Right. Now, what are the names of those stages? This one, first stage we call workspace. Second stage we call either staging area or indexing area. Staging area or indexing area. Third stage we call local repository. I'll explain purpose of each stage. Okay. These are the names. It happens by default. That means the moment you run git init, that's it. That will be divided into three stages, and those names are workspace, staging area, local repository. Fine. Now what you do? Assume that you are a developer. Assume you are a developer. Sai is a developer here. Now he will create one file, any name you can give, and he's going to write some code. Focus on only black color. He's going to write a bit of code. From morning till night, he spent a lot of time. He has written a lot of code for that IRCTC application. You can see the black color. Okay, he finished his work. Before he leaves his office, what he's going to do, he's going to run add command. The moment he runs add command, what actually happens? That file along with the data, black color data will go and sit here. The copy of the file along with the data will go and sit here. The moment he runs add command. Okay? That file will go and sit in staging area. Then again, he will run one more command, that is commit command. He's going to commit. Then that file will go and sit here along with the data. Okay. So after finishing his work, he's going to run add command. He's going to run commit command. Add command will send one copy to staging area. This one. Commit command will send the copy of the file along with the data to local repository. Where inside repository? Inside branch. See, the moment you run git init command, you will get three stages. Correct. In the local repository stage, you will get one branch automatically. One branch. I'll talk about purpose of branch later on. Earlier, the name used to be master earlier, but recently they have renamed it. The branch name is going to be main now. Main. That will be there by default. By default, that will be there. So the moment we run commit command, then the copy of the file along with the data will be sent inside the branch. Inside the branch. Understood? That's it. That means what I do, I create a file, I write some code. Once I finish my work, I'll add, I'll commit. That's it. Only two things. Add and commit. Okay, I finish my work. That's it. Then what actually happens in company? Assume that there is a Raj. Mr. Raj is he's a team lead. Team lead means who leads a team. So these two guys, they come under Raj. Okay, the Raj is a team lead. What Raj is going to do, he will go to GitHub, and he will create one repository. Okay, repository. See, Google Drive belongs to Google. Google Drive belongs to Google. Correct? In the same way, GitHub belongs to Microsoft company. Purpose of Google Drive is what? To store the data. Correct? Here also same thing, we store the data. But Google Drive, we store movies, pictures, songs and all. GitHub, we store the code. That's it. That's the only difference. So GitHub is an online storage being maintained by Microsoft company, which is your inside. We are going to store our code. Right? Same like Google Drive. Google Drive belongs to Google. GitHub belongs to Microsoft company. That is the only difference. Understood? That is the only difference. See, if I want to share my code, suppose, see, I want to share one document with you. How I share? I'll upload to WhatsApp. From WhatsApp, you'll download. Correct or not? Or I'll upload to Google Drive. You'll download from Google Drive. Or I'll upload to my mail. You will receive that mail. You'll download. So I need one online storage, right? I need one online medium where I can upload. From there, you can download. Correct or not? Right? So here also, I need one online storage where I can upload the data. Someone can download the data. That is what here we are using GitHub. Okay, GitHub is online storage being maintained by Microsoft company where we store code. That's it. That means the entire concept is Git. Entire concept. In that, GitHub is a small portion, online storage. Sai, is it mandatory to use GitHub only? No need. You can use Bitbucket also. Bitbucket. This belongs to Atlassian company. Atlassian company, which is located in Australia. You need anyone online storage. You need anyone online storage where you can upload the data. Someone can download the data. Okay. Microsoft company is providing online storage called GitHub. Atlassian company is providing online storage called Bitbucket. You can use anyone online storage. The most popular one is GitHub. Belongs to Microsoft company. Understood? So GitHub is online storage. It's a part of Git. Understood? Right. So what this team lead, he will do, Raj, the team lead, he will create one account in GitHub by the company's official email ID. Then he will create one repository. You can give any name. I'm giving central repo. The way in Google Drive you create folder. The way in Google Drive you create a folder in which you upload files, correct? Movies, pictures and all. In the same way, here we create repository. We create repository in which we upload the data. That's it. So what I do, once I finish my work, I will add, I'll commit, then I will push. I will push. Once I push, then that file along with the data will go and sit here. Along with that data will go and sit here. Clear? Right, remember that. So only 3 things that I'm going to do. Once I finish my work, before I leave my office, I will add, I will commit and I will push. That's it. I finish my work. I finish my work, then Hari will start his work. For me it is night, for Hari it is morning. Right? What Hari is going to do? Hari will do the same thing. He will launch one EC2 instance. He will install Git. He will create one folder. He will go inside the folder. He will run Git in it. Then he also will get all 3 stages. Correct? All 3 stages. Right. Inside he will get branch also same. Exactly same. Then he will not write any code. He will not write any code. First he is going to pull that code. He is going to pull the code first. First he will pull existing code. I told you, right? We have written 10% of code we pushed. Then Hari will pull 10%. On top of that, he will add 10 more percent. On top of existing code. Got it? For example, I have already created IRCTC login page. I pushed that code. Then what Hari will do, I will pull that login page related code. Then I will work on second page where we enter client details and all. Clear? That is all. So Hari will pull that existing code. The moment he run pull command, then automatically that file along with that data, black color data, will come here, here, here in all 3 stages at a time. It will come to all 3 stages automatically. Okay? All 3 stages. Automatically it comes to all 3 stages. Then what he will do, Hari will write some code. Focus on blue color. You can see Hari will write this blue color code, blue color. Then once he write from morning till night, he spend a lot of time. Then after finishing his work, he will add. Then that blue color data will go and sit here. Only the data, whatever he has added, that will go and sit here. That copy of the data. Then he will commit. That blue color code will go and sit here. Because the file black color code already is there in all 3 stages. Only whatever extra code that he has written, that will go and sit here, will go and sit here. After adding, after committing, Hari is going to push. Then that blue color data will go and sit here. Whatever data which is there in his machine, which is not there here, not there, that only will go. Because black color data is already there. So blue color data will go and sit here. That's it. Hari finished his work. Means he has added blue color data. He added, he committed and he pushed. That's it. We got blue color data. Okay, Hari finished his work. Then for me again, we need to start our work. Before I start my work, I need to pull existing data. I need to pull. Once I pull, then only that blue color data I get. In all 3 stages at a time. Black color earlier it was there, already it is there. Now also, whatever data which is there here, which is not there here, that only I get. Okay, I got blue color data in all 3 stages. Then what I do, I work on some other code. I work on pink color code. I write pink color data from morning till night. I have added, I have committed. Again I pushed. The pink color data went here. Then again, what Hari will do? Hari will pull. Then he will get pink color data in all 3 stages. Then he will work on again that green color data. After writing, then add, commit, and push. Understanding, right? That is how things work. That is how things work. Okay? Only 3 things. Add, commit, push. This guy will pull, again, write a new code, add, commit, and push. Again, what we do? We pull, then we write extra code, add, commit, push. That is the workflow of Git. Very simple. So that the actual final code, the copy of the code will be here, here, here. Everyone's machine will have the copy of the code. Got it? That is the workflow of Git. I hope you understood. Right. Now let's focus on the term, the same image from here only I have taken. Okay. Now let's focus on the important terms. Repository. Also we call depot. In Git we call repository. In other source code management tools we call depot. Okay. What is repository here? It is just a folder. You can say here. Understand one thing. This is central repository, this entire circle area. It's kind of folder here. It's kind of folder. Local repository is what? Actually, this entire folder also we call local repository. And this for this stage also we call local repository. Then sorry, there's a confusion. When I use our local repository, what do I mean? I mean this folder or this particular section? That depends in which scenario you are using that word. Hindi mein kal ka meaning kya hai? What do you mean by kal? Tomorrow, yesterday also. Correct? Kal hoga means tomorrow. Kal tha means yesterday. Correct? Brother. Brother means what? Younger brother or elder brother? Both. Correct or not? Here also same thing. When I talk about local repository versus central repository, local versus central, big terms when I use, that time local repository means this entire folder I'm talking about. Entire folder I'm talking about. Okay? But when I use the word workspace, staging area, local repository, that time local repository means I'm talking about this particular section. Actually, workspace and staging area, they're part of local repository. They're subsections of local repository. Understood? So when I use the word local versus central, when I use these big terms, that time local repository means this entire folder. Entire folder. But when I use the word local workspace, staging area, local repository, that time I'm talking about this small area. Understood? Remember that. Okay, remember that. Fine. Now here, repository means folder. Repository means folder. This one means this is one folder, means local repository. And this is also kind of folder only. Okay, so we call central repository. This one we call local repository, this one we call central repository. You can give whatever name that you want. Here I have given for local repository Mumbai Gate. You can give whatever name that you want, that's up to you. Okay, any name to that one. Then server. Server means what here? We are talking about EC2 instances. This is one server. This is one more server, EC2 instances. Understood? And one more thing. In this entire server, only Sai will work. No other user will log in. Remember that. No other person will log in. So here there is no concept of users permissions and all. No. Only one person will log into that machine. He will work as a root user. No one else will log into this machine. Remember that. Clear? So this entire machine belongs to only Mr. Sai. Understood? Right. Then workspace, work directory or work tree. Workspace, work directory or work tree. It's a place where you work, where you create, edit, delete files. That means here, this is this area I'm talking about. This particular section. This particular section. Workspace, you can call workspace or work tree. Okay, or workspace or work tree or work directory. Yes, workspace, work directory or work tree. You can use any of these words. Observe carefully. In all these ways, where actually we are creating the file, we are writing some data here only, correct or not? We are creating a file, we are writing some data. Later on, we are adding, we are committing, we are pushing. That means we are not physically working on these files here. We are not physically working here also, correct or not? Add means what? Send a copy of that file. Commit means send a copy of that file here. Push means send a copy of the file here. So where actually we are working? We are working in only one place, that is here. Correct? This area only. We are not working here, we are not physically working in that file. Here we are not working here also. Correct or not? Even when Hari pulls that data. After that he wants to add some data, he is adding here only. Then he is adding, committing and pushing. So literally where we are working, we are creating the file, we are writing some data, we are modifying the data. Where? In workspace only. So workspace is the only place where you create a file, where you write some code. If you want to edit, you can do edit here only. You can't work here in these stages. Remember that. Okay? That's why they have a name called workspace, where you work physically. You work. Okay. Then coming to branch. What do you mean by branch here? You can see local repository has a branch. When you run git init, I told you, right? These three stages will get created automatically. That's what I said. In this local repository stage, you will get one branch automatically. Earlier the name used to be master, but recently they have renamed it to main. You will get by default. So once you commit, where that file along with the data is going inside the branch, correct or not? Right, inside the branch. Now what is the purpose of this branch? First of all, why do we need this branch? Let me explain. Assume that you are attending drawing competition. Okay, in childhood days we used to attend drawing competitions, right? Right, school level, inter-school level competitions, right? Inter-class level, right? In that, assume that you are good at drawing. Then in that competition you get one paper, correct? In which you have to draw something. Okay, you have to draw something. Let's say paper name is X. You have to draw something here. What you did? You finished your drawing. 50% of drawing you finished. 50% of drawing already finished. But before you finish the remaining 50%, you got two ideas. But you don't know which idea looks good. When you will come to know which idea looks good, when you practically implement it, then when you see physically, then you'll understand which one is looking good. Okay, see, you finish 50%. After 50%, you got two ideas, but you don't know which one to implement. Okay, you can implement only one idea, but you got two ideas in your mind. You have to choose the best one. But when you will come to know which one is best one, when you practically implement it, when you put it in a paper, then you see with your eyes, then you'll understand, okay, this one is looking good, correct or not? But only one paper, two ideas. Then how to implement it? Then what you do? You take a photocopy of that one. You take one photocopy. Two photocopies you take. Okay? Yeah. So when you take photocopy, exactly, that's what Xerox. You'll get the same diagram. Let's say this is first photocopy, this is second photocopy, right? Then what you did, you implement first idea in first photocopy, first Xerox paper, second idea in second Xerox paper, right? Then you verify, okay, which one is looking good. You have seen, you have observed, okay, seems ready is looking good. If you, like for you, the second idea is looking good. Then what you do, you implement that second idea, correct? Okay, then you submit the main paper, that is X, correct? Let's say if you don't have this photocopy option, can you implement both ideas? Can you, verify which idea is looking good? You cannot, right? So here this photocopy means when you have two copies, it helps you a lot to implement both ideas. From that you pick the best one, right? That means here we need multiple papers. We need these multiple papers to implement new ideas, correct or not? To implement new ideas, right? That is one scenario. What is the first scenario? To implement new ideas. Okay, to implement new ideas. That's what, when you get any new idea that you need to implement, for that you need two papers, right? That is one scenario. Let's take one more use case. One more use case. You are, say, you have a drawing competition. You need to draw two diagrams. You need to draw two diagrams. Okay, two big lengthy diagrams. What you can do, you can, see, you first you finish one diagram, second you finish another diagram. That you can do. But continuously working in the same one makes us feel bored, right? We can't work on the same task continuously. I generally feel bored. Everyone feels bored, correct or not? Everyone feels bored. That's why what you can do in that case, same, you take two papers. Two papers. Okay, you take two papers. One second. You take two papers. First you implement, finish your 20% of the diagram. Okay, you feel bored. Then again you go here. Again you finish 10%, 20%. Again you come back here. Again you go there. Again you come back here. Again you go there. Again you come back. Again you go there. So if I work in this way, then I won't feel bored. But working continuously in the same diagram, it really, sometimes we feel bored. Correct or not? We feel frustrated. Correct? We fed up with that work. Similar kind of work. That is the reason in our school days, day gets divided into multiple periods, right? In one class, we study, English, second Hindi, then some local, local language or state language, then math, science, social. That is how we studied. Not like, we finished English, entire English course, then entire Hindi, then entire math. Not right. Not in that way, right? Because this is not a good way. I mean, we feel bored working on the same one. That's why initially, here also, I work on one diagram. When I feel bored, I switch here. Again, when I feel bored, I come back. Again, when I feel bored, I here. Correct or not? So here I need multiple papers to work on multiple tasks simultaneously. To work on multiple tasks at a time. Correct or not? To work on multiple tasks simultaneously. Here also we need two papers. Here, okay, got it? Let's say you got only one paper. You are getting one paper after another paper. You got only one paper. Then you need to finish one task completely. After that only, let's assume that you are getting another paper. Then in that, then you need to work on that second task. But this way we feel bored. Let's say if you get two papers at a time, then you work here a little bit. Again you go switch there. Again you come here. Again you go there. Right? In this way we can work on multiple tasks. So here we need multiple papers for two purposes. The first one is to implement new ideas. Second one is to work on multiple tasks at a time. Right? In the same way, here also we need branches. We need branches. For what? To implement multiple ideas and for doing multiple tasks at a time. Okay, that means here the diagram will be something like this. By default, we get one branch called main branch. By default. What I did, I create multiple branches. Let's say branch A, branch B. Okay, I am going to create two branches, two extra branches, branch A and branch B. Then what I do here, suppose focus on first advantage. I want to implement new ideas. Then what I do here, I create one file. In that I will write some code. I add and commit here. Okay. Then I create one more file. I will add and commit here. Okay. In first branch I will implement the first idea. In second branch I will implement second idea. Then I'll verify which one is looking good. Which one is looking good. Okay. Let's say this branch B code is good. Then I will merge. Merge means what? Copying the code from one branch to another branch. That is what we call merge. I'll merge. From here, I'll push to central repository. Got it? And I hope you understood. One idea. Idea means what? I'm writing code. Okay, I got two ideas in my brain. That homepage, how homepage should look like. I got two ideas. So one idea related code, I saved here. Another idea related code, I saved here. I verified. Then I got to know, okay, B is looking good. Then I merge that code to main branch. From here, I push to central repository. Got it? That means here I need branches to implement new ideas. Got it? So how many ideas you can implement? Any number. That means how many branches we can create? Any number. There is no limit. If you have 10 ideas in your mind, you can take 10 branches, implement all ideas, and you verify and you use the particular one. Whatever that you feel like looking good. That is first purpose. Second purpose is, at a time I want to work on 2 web pages, login, logout page, and also where you book the train tickets. Both I want to work. What I do, I create one file. I'll write, that's what, I will keep, I'll write the code for login page, I store that code here. In branch A, I keep storing login and logout page related code. And in branch B, I keep storing where you book the train tickets, that page related code. So here, whenever I feel bored, I switch here. Whenever I feel bored, I switch here. Okay? One task related code I keep here, and the task related code I keep here. Then I need both, obviously, multiple tasks. I need both of them. Then I merge this one here, this one also here. The entire code will be here. From here, I'll push to central repository. That means in this case, these 2 branches are needed for me to implement, to work on multiple tasks at a time. Here, both the tasks are important. That's why I merge here, here. Merging means copying code from one branch to another branch. Then from here, I push to central repository. Got it? Right? Here, so far, earlier, when we had only one branch, from there, we used to push to central repository. Okay, from there. Now here, what did I work on? Multiple branches. Okay, then I merge it to main branch here. From here, I push to central repository. Simple. That is the purpose of branches. Pretty clear. Okay, only 2 advantages. One is for implementing multiple ideas. Multiple ideas are there, you want to implement. So for that, for each idea, we need one branch. For that, so that we can pick the best idea. And also for doing multiple tasks. So that we don't feel bored. Okay, so that we can work in both tasks at a time. Here, little bit, again here, like that. For that, we need branches. Understood? Right. That same example, drawing competition is a best example for this. Product is same, one repo, but different tasks are different ideas. IRCTC, product is same. That's why one repo. One repo means one local repo for me and one central repo for all. Okay? But multiple ideas are there. Or I want to do multiple tasks at a time. For that, we have multiple branches. Got it? Multiple branches. Understood? Right. Each task or idea. Guys, here, when I'm using the word task means I want to do multiple tasks at a time. When I'm keeping idea means I want to implement multiple ideas so that I can pick. When I'm implementing multiple ideas, so that I can pick the best idea. When I'm doing multiple tasks means both are important, and I work on both tasks at a time. Okay? So for any of these reasons, we need multiple branches. So that each task related code I keep in that branch, or each idea related code I keep in that branch. Finally, we merge code of all branches. We don't merge code of all branches. Whatever the code that you feel like it is correct, that you merge. Like when you're implementing two ideas, then whatever idea you feel good, that you merge. When you're working on multiple tasks, then you need both tasks, then you merge both branches related code in main branch. Understood? Right. Okay, finally we merge the code. Merging means copying the code from one branch to another branch. Based on a requirement, we merge. So we need multiple branches. The branches are needed for parallel development. Parallel development when you are working on multiple tasks. Parallel development means I am working on both tasks at a time. That is what parallel development. I am developing both web pages at a time. Login page, logout page, and also where you book the train tickets. When you are implementing ideas, then to implement new ideas. Okay. So for that we need branches for parallel development and to implement new ideas. Okay. Can create any number of branches. Literally that is up to you. There is no limit. But generally we don't keep more than 2 or 3 because the more branches you create, the more confusion it creates. That's why generally we keep not more than 2 or 3. Okay. Changes are personal to that particular branch. That means when you create a file here, when you add and commit here, whatever code you store here, these 2 will not come to know. Whatever code you store here, these 2 will not come to know. Got it? So whatever you do in one branch, other branches will not come to know. Until you merge. Once you merge, then only the data is going here. Otherwise, no. That means whatever you do in one branch, other branch will not come to know. 2 papers are there. Whatever you draw something here in this paper will not come to know. Whatever you do, this will not come to know. Correct or not? So changes are, here changes means I'm talking about the code. Changes are personal to that particular branch. Means the code, whatever you keep, that is personal to that branch only. Other branches will not come to know. Can put files only in branches, not in the repo directly. Can put files only in the branches, not in repo directly. Means here, once you are committing, where the file is going inside the branch only. Got it? Remember that. You can't directly keep inside this repo here. No, that is not possible. You are going to bank and you want to save your money in the bank. You go to bank and you throw money inside the bank? No. You create an account. Inside you store that account. You save the money. Here also, once you commit, the data will go inside that branch or any one of the branches. Okay? Like that. That means here, once you create a file, once you add and commit, that data will go and sit any one of the branches. Not to directly, you can't directly store code here. No, that's not possible. Remember that. And default branch name is main. The default branch name is main. Earlier they used to give a name as master earlier, but now they are giving name as main. These are default branch. Whatever they are giving, that name is main. But again, don't think that main branch means, it will control other branches. No, nothing like that. Nothing. Just they are giving one branch, that they are giving name as main. You can create your own branches. You can give whatever names you want. Okay, for example, I can give a name called master. Here I can give a name called leader. Don't think that this will control other branches. No, all are same only. Just they are giving one by default. By default. That means it is not necessary that you work in these branches and you merge here only. No need. No need. Let's say already they are giving main. You create two branches. You implement one idea here and another idea here. Whatever idea you feel looking good. Okay, let's say B is good. Then you merge in main branch. From there you push. Generally, the branch from where we push to central repository, in that branch, we don't use that branch for testing purpose. We don't use that branch for testing purpose. See, you got one paper, immediately you took photocopy. So total all three are blank papers. You keep any one paper for submission, correct or not? That paper you don't use for rough work, correct? Generally, that paper, the one you decided to submit. So you can choose any one paper which you want to submit finally after finishing diagram. Let's say I keep this one for submission. So then I don't use this one for testing purpose. All rough work, diagrams, everything, that I do in these two. Here also you keep any one branch only to push to central repository. You decide which one you want to keep. So in that, that one you don't use for testing. Remaining other branches you use for testing, either to do multiple tasks or to implement new ideas. Okay, finally, once you finish your work, then you merge to this branch. That branch you use only for pushing purpose. Got it? So that's why don't think that, that giving main will control other two branches. No, nothing like that. All are same to same. But you keep one branch, not for testing purpose. Got it? Right. Just the name they're giving as a main. Many people, they get confused. Main means it controls other two branches. No, not like that. I have a dog in my house. The name of dog is Tiger. The name is Tiger. It doesn't mean that it will become Tiger. No, right. Dog means dog only. Here also same thing. Name they have given as main. It doesn't mean that it will control other two branches. No. Clear? Then. This point you can leave it as of now because this you will not understand now. I need to show practicals. Then only you will understand this particular point. Okay, let's keep this one aside that we will discuss later on. I mean, you won't understand even if I explain now. Okay, right. What do you do? Let's take a short break. We'll have one more session today, continuous session. Okay, short, just time is 10:37. Stay connected only. We'll have second session at 10:45 p.m. Okay, just 8 minutes break. Is that fine, everyone? Stay connected only. I'm not going to stop the meeting. Is that okay or not, everyone? Maybe yes or no? Right. We'll continue from 10:45 p.m. 8 minutes break. Thank you. Thank you all.